This Edpuzzle video is just finishing the rest of the Unit 0 study guide. So this is the next page in it, so go ahead and flip through the next page, significance tests. Alright, so I have 4 different articles listed, or when I say articles, I mean quotes from articles that have statistics in them. The first thing we're going to do is determine the variable, and the second thing we're going to do is write the hypothesis using context. And then I'll go ahead and tell you what will be on the test and what won't be on the test. Alright, so starting off with letter A, this week's survey from The Economist/YouGov found that 41% of Americans considered the protesters themselves mostly peaceful. Alright, so I'm going to circle the statistical words. 41% of Americans considered the protesters themselves mostly peaceful. Alright, so I know that if I'm circling percent, my variable is going to be P. Alright, now let's go ahead and write the hypothesis for this. Alright, I will be the first to admit I did not do a great job at explaining writing hypotheses. So, on your test, you're only going to have to write hypotheses using P, mu, and the equal sign, and the not equal sign. So that's all you need to do. Don't worry about difference of P's or difference of mu's, and don't worry about the greater than, less than, all that. All you need to know is a single P, a single mu, and the equal sign, or the not equal sign. That's it. Alright, so let's go ahead and do A. This week's survey from The Economist found out 41%. Alright, so the main thing that I need to know about this P is that I need to translate it to a decimal. Can I do that? I know you guys are all waiting to see if I can, and I can. Alright, so 0.41. So I'm going to say my H null is that P is equal to 0.41, and my HA is that P is not equal to 0.41. Alright, so looking at this survey found that 41% of Americans, so we're going to say P is equal to 0.41 or P is not equal to 0.41. It would not be correct to write 41. It's a percent, so or proportion, so we need to write it as a decimal. Alright, now the only other thing that I want you to add here is we're going to define what P means in context. That's getting you ready for the AP exam where you'll get context points. These numbers mean nothing to me as a reader unless I define them, right? So I'm going to say where P is the true proportion of Americans who considered the protesters themselves mostly peaceful. Alright, I already know you're groaning. But so do I have to write this entire thing? Yes, the downside, or the upside, depending on who you are, is that statistics involves a lot of reading and writing and interpretation. So this defines exactly what P means for us. If I just looked at this and wondered what does that mean, I would have no idea. The article gave me context, and I'm just going to state that context in statistical interpretation form, right? So H naught, or H null, is P is equal to 0.41. HA, or my alternative, is P is not equal to 0.41. Where P is the true proportion of Americans who considered the protesters themselves mostly peaceful. I need the word true and I need the word proportion. And then the rest of it I just got from the article title. Alright, I want you to go ahead and give B a shot on your own. So B. I want you to go ahead and try B on your own, everything, right? This and this. So pause that video. I see you, CJ. Pause the video. Just kidding. I bet CJ paused it. Alright, so Giannis is 30.4 minutes per game during the regular season, were his fewest since his rookie year. Alright, so the most important statistical thing here is 30.4 minutes. So he's averaging 30.4 minutes per game, right? So if I have a number, not a proportion or a percentage, then I know that I'm using mu, that Greek letter mu. Oh my gosh, I spelled mu with the Greek M. I just need the Greek letter. Alright, so let's go ahead and write our H naught and our HA. Remember, when we have mu, it doesn't have to be between 0 and 1. So I'm going to say mu is equal to 30.4, and mu is not equal to 30.4. Remember, my null always has the equal sign, and my alternative always has that not equal sign. Alright, so the last part is just defining it. So, where mu is Giannis's average minutes per game during the regular season. You're basically explaining to me as the reader, what does this number mean? It's Giannis's average minutes per game during the regular season, and I should say this year, right? That's important. This year. All right, we're telling our statistical story here. It's important. So Giannis's is, I forgot the word true. Don't forget that word true. It's important when we're talking about hypotheses that we use the word true. All right, so true proportion or true average, where M is Giannis's true average minutes per game during the regular season this year. All right, pause that video and try C. All right, I was very basketball themed here. Kawhi Leonard averaged 6 assists per 100 direct post-ups in last year's playoff. All right, I'm not really sure what that means. Assists per direct post-ups, whatever. Okay. So if we are averaging 6 assists, I know that this right here looks like it could be part of our hypothesis, but it's not. It's part of the context. It's not part of the hypothesis, it's part of the context. All right? So if we're averaging, or mu, our H null was that mu is equal to 6, and our HA is that mu is not equal to 6. Now let's go ahead and define what that means. So I'm going to say where mu is Kawhi's true average assists per 100 direct post-ups. In last year's playoffs. All right, I had the word true and average. Remember, I need either true proportion or true average depending on what my variable is. All right, go ahead and pause the video and try D. Okay, D, a new survey from Morning Consult found that 28% of Americans felt the Food and Drug Administration based its decisions concerning COVID-19 treatments and vaccines on political pressure. Well, that's not good. All right, so let me circle 28% of Americans. So percent, I know I'm dealing with P. So let's go ahead and write my H naught, which is my null. We're going to say P is equal to, now is it 28 or 0.28? Hope you said 0.28. And my HA is that P does not equal 0.28. So looking at these, you see my P's are always a decimal, and my mu's could be or could not be, right? It doesn't matter with mu. All right, let's go ahead and define what this means. Remember, the words I need here are true proportion. All right, where P is the true proportion of Americans who feel the FDA, and I'm just pulling this straight from the article title, who feel the FDA, I abbreviated Food and Drug Administration to FDA. We can abbreviate in stats. All right, who felt the FDA based its decisions concerning COVID-19 treatment and vaccines on political pressure. All right, great work, everybody. Let's go ahead and flip it over. All right, I think we only have, oh, my bad, no, we have more. All right, so using the p-value to make a conclusion. So this should go pretty quick. Remember, if the p-value is small, the null will fall. So if my p-value is less than my alpha level, we reject the null. If my p-value is large, the null is in charge, we fail to reject. If the p-value is small, the null will fall. If the p-value is large, the null is in charge. Take it or leave it. All right, so looking at this, we just need to figure out which one's smaller, which one's larger. So 0.02, 0.01. It looks like 0.02 would be bigger. All right, so if my p-value is larger, I'm failing to reject. So I would fail to reject the null. All right, pause the video and go ahead and try the rest of these on your own. Write out the conclusions. All right, I'll give you a second to look through these and check your work. So my p-value was larger here, so we were failed to reject, and for the rest of these, my p-value is smaller, so we're rejecting the null. All right, so interpreting the conclusion. So basically, we take our conclusion and we want to interpret it in context, right? Does it mean that our claim was true or not true? So when we reject the null hypothesis, sorry about your teacher's typo, what does rejecting the null hypothesis mean? It means the null is probably not true. That's the best. Oh my gosh. Don't show that to Mr. Pat. Wow, that's embarrassing. Probably not true. That's the best we can do in statistics, is probably not true. All right, what about failing to reject the null? If we fail to reject the null, that means the null is probably true. All right, so we're going to take all of those articles and we're going to write the different interpretations between rejecting the null and failing to reject the null. So let's go back to the last page. All right, so our null for this one was p equals 0.41, right? So 41% of Americans considered protesters themselves mostly peaceful. So if we rejected the null, we would say the true percentage of Americans who think that the protesters were mostly peaceful is probably not 41%, because that was our null, right? I'm going to flip back 0.41. If we failed to reject the null, the true percentage of Americans who think that the protesters were mostly peaceful is probably 41%. So the only difference between the two is probably not and probably. Feel free to try and do the interpretations for the other 3 articles, but the main thing that I wanted you to know here is that if we're rejecting the null, it's probably not true, and if we fail to reject, it probably is true. All right, confidence intervals. All right, so you need to know how to create a confidence interval given a point estimate and a margin of error. Okay, so remember your confidence interval formula is point estimate plus or minus the margin of error. So your point estimate is right in the middle of the interval, and then you add and subtract the margin of error to get your lower bound and your upper bound. All right, so France has been heavily affected by the severe acute respiratory syndrome coronavirus, SARS-CoV-2 pandemic, and went into lockdown on March 17th. Using models applied to hospital and death data, we estimate the impact of the lockdown and current population immunity. We find that 0.5% of infected individuals die, and this is a margin of error is 0.2%. All right. So I pulled this from an article. All right, so we're going to create a confidence interval, but first let's identify the point estimate, and let's identify the margin of error. All right, so looks like we find that 0.5% of infected individuals die, and the margin of error is 0.2%. Since we're dealing with percentages, we're dealing with P. Since we're dealing with P, we need to convert these percents to decimals. They're not already decimals. Do you see that percent behind it? So to convert it to a decimal, I'm going to take it and move it to the left twice. So my point estimate is going to be 0.005. If I were to take that number and multiply it by 100, that would give me my percentage, right? Because 10% is 0.1. And when I multiply it by 100, I get 10, right? That works. 0.27 is 27%. When I multiply it by 100, I get 27. Let's try this here. When I multiply it by 100, I should get my percent, which is 0.5%. So I did it correctly. Now let's go ahead and convert the margin of error to a decimal as well. 0.02. To check my work on conversion, I'm just going to take that and multiply it by 100, and it should give me my percentage, which it does. All right, so we're ready to create the confidence interval with my lower bound and my upper bound. Remember to always put the lower bound number first, so I'm going to subtract first. I'm going to do 0.005 minus 0.002. All right, so it looks like my lower bound number is 0.003. To get my upper bound number, I'm going to add plus the margin of error. All right, so here's my confidence interval, 0.003 to 0.007. All right, among all registered voters, Trump leads Biden by 1 percentage point, 48% to 47%. The poll was conducted August 31st through September 6th among 766 likely voters with a margin of error of 4.5 percentage points. All right, so let's say 4.5 percentage points is my margin of error. So we have enough information for 2 confidence intervals. We have enough to do a Trump confidence interval and a Biden confidence interval. So for my Trump confidence interval, I need a point estimate and a margin of error. All right, my point estimate is going to be Trump's number. If Trump leads Biden by 1%, which one is Trump's number? All right, I hope you said it was the 0.48. Remember, I'm converting percentages to decimals here. And then my margin of error is the same for both Trump and Biden. It's 0.045. Remember, I had to convert that as well. All right, so let's go ahead and do our Trump margin or confidence interval. My 0.48 is right in the middle, so I need to subtract the margin of error to get the lower bound. And I need to add to get the upper bound. All right, this is my Trump confidence interval. Let's check and see about Biden. Point estimate and margin of error. My point estimate for Biden is the other percentage, right, which is the 0.47, but I have the same margin of error because the poll was just done once, right, so I have the same margin of error for both. So let's go ahead and get his lower bound and upper bound. 0.47 minus 0.045 gives me 0.425. 0.47 plus 0.045. All right, you notice how these two numbers overlap, right? So if Trump's true number was on the bottom end and Biden's true number was on the top end, then Biden would be leading Trump, right? So it just goes to show that 1 percentage point with that wide of a margin of error is not telling us much, right? The race is very close. That's what it's telling us. All right, determine a point estimate and margin of error given a confidence interval. All right, so this is just math, right, you guys? You're going to find the middle number between these two by subtracting and dividing by 2. So I'm going to take my top number minus my bottom number. I'm going to divide that by 2, and this gives me my margin of error on each side. All right, so if I've got my margin of error, and I'll just go ahead and label it margin of error, then I can figure out the point estimate in one of two ways. I can add it to the lower value, or I could subtract it from the upper value. Either way, I should still get the same number. So let's go ahead and check it. All right. So this is my point estimate. This is the number exactly in the middle of the interval. And this is my margin of error. So go ahead and pause the video and try B and C on your own. Okay, so here's what I got for the point estimate and the margin of error. So go ahead and check your work if you didn't get one of these two numbers, and if you're still not figuring out how I got the point estimate or margin of error, I want you to type what you're getting in the answer box now so I can follow up with you. All right, the last page has to do with interpreting a confidence interval in context, right? So we did this on the last Edpuzzle video where we're given a confidence level and an interval, and we're defining what P or mu is. Okay, so A, confidence level 90%, confidence interval 0.3 to 0.35, and P represents the true proportion of students who prefer virtual learning to face-to-face. So my interpretation would go like this. We are 90% confident I saw somebody use the word sure. I want you to use confident because it's a confident interval. We are 90% confident that the true proportion of students who prefer virtual learning over face-to-face is between 30% and 35%. All right, if you use the decimals, that's fine. If you use 0.3 and 0.35, but if you use the decimals, don't use the percent symbol, right? You need to stick with one or the other. If you're using the percent symbol, convert it to a percent, 30% and 35%. All right, I want you to pause the video and try B and C on your own, and then come back and check your work. Here's the answer for B. We are 95% confident that the true average number of questions Ms. Lucas's students will answer correctly on the Unit 1 summative is between 18 and 20 questions. So I underline the important parts that I really want you to have word for word. All right, go ahead and try C. All right, so with C, we are 98% confident that the true proportion of Falcons fans who successfully blocked out that terrible Super Bowl is between 73% and 99%. Now, I hope if you put the percent sign, you do not have a decimal, because 0.73% and 73% are very different. So you're either using the decimal like this, or I recommend you convert it to a percentage, because that's easier to interpret and understand. All right, great work, you guys. The last part. Determine the effect of the confidence level on the range of the interval. So remember that Garfield cartoon where the range was really big, but we were also extremely confident because the range is really big? So think about that. If we're going from a less confident level to a more confident level, if I'm changing from 90% confidence to 95, that means I'm more confident in my interval. So if I'm more confident in my interval, like that weatherman, it must be a big interval, right? So if I'm going from 90 to 95 confidence level, that means I'm making a larger interval because I'm more confident that the true number is in there. All right, let's try from 98 to 99. All right, here I'm still going up. I go up from 98% to 99%. So if I'm going up in my confidence level, my interval must be getting larger. All right, with C, I'm changing the confidence level from 85 to 80, so I'm going down. I'm less confident. If I'm less confident, that means my interval must be shrinking. All right, I want you to try D on your own. Just think of that Garfield cartoon with the huge interval and the weatherman being 100% confident. Okay, so going from 92 to 90, my confidence level is decreasing. So I must have a smaller interval to be less confident. All right, let's see the effect on the confidence level. So we're just kind of doing this in reverse. So my interval is going from 10 to 20, 10 to 20, and now it's from 5 to 25. So did my interval get bigger or smaller? It actually got bigger, right? My range here was 10, and now my range here is 20. So my interval got larger. That must mean I increased my confidence level. My interval is getting larger, I increase my confidence level. All right, here my interval is getting smaller. So if it's getting smaller, I've got less options, right? So I'm going to decrease my confidence level. All right, I want you to take a second and try G and H on your own. Right, for G, my interval got smaller, which means I decreased my confidence level. And then here, my interval got larger, so that's increasing my confidence level. So I just want you to kind of remember that correlation. That's a word you'll know soon. So if my interval is wider, my confidence level also goes up. If my interval is smaller, my confidence level also goes down, right? If I have less numbers to choose from, if I have a smaller interval, that means I'm less confident. All right. Have a good weekend.